Let us take this problem from the chapter of friction. The problem says a car starts from rest on a half a kilometer long bridge. The coefficient of friction is such and such, so that one cannot drive through the bridge in less than 10 seconds. In fact, this problem is not at all difficult, but I have taken it up for your understanding. Once you understand the problem and you can plan your solution, the remaining things are easy. The car is on a half a kilometer long bridge. Let's say this is a bridge. Car is on a half a kilometer long bridge, and length of this bridge a kilometer, that is 500. And says there is a car. The car here is trying to move in this direction, let's say. And the coefficient of friction is 1. Take the force diagram, force components. This is downward is mg. Upward is reaction force R. In this case, R is equal to mg. And since the car is moving towards left, we have considered when the tire is on the car and the tire tries to revolve, the tire goes from left to right when the tire is surface of the road. So the road applies the opposite force, which is equal to frictional force. And this frictional force is actually the force which drives the car. This frictional force is equal to mu R, which is equal to mu h. Here, this actual logic here, mu is equal to 1. That is maximum. This is maximum. That means the frictional force can not be higher. That means frictional force cannot be higher than mu mg, since mu is equal to 1, so this is equal to mg. We write since mu is equal to 1. And frictional force cannot be any higher. That means the force which actually takes the car from right to left or make the car move is the highest. This is the actual hidden logic of this particular problem. This we have to understand clearly. Once you have to understand clearly, then we can easily say that means the car at its highest capacity. It cannot move any faster. So this is mg, and mg is equal to this mg, and that means, so if you consider The horizontal forces, horizontal power. Consider the horizontal forces on the car. Then we find the force mg. Force mg actually produces the acceleration A on the car of mass m. That means m and m gets cancelled. Therefore, you get acceleration A is equal to g 10 meter per. The acceleration A is 10 meter per second square. Since we have the acceleration A and we have the length of the pitch 500 meter, so it is easy now to find out. Use the formula. Use the formula S is equal to half A T square. Time is indicated here is 10 seconds. So from this equation, we find time. So S is 500. Car starts from rest, so U is 0. Half into A is 10 into square. So this two gets cancelled. We have 5. So from here, we find T square equal to 100. That means T is equal to 10. So it is proven that the maximum speed, the car is already moving at the maximum speed. So minimum time is 10 seconds. That means the car cannot drive through the pitch in less than 10 seconds time. Fine? Then you go to the next problem. You go to the next problem. In this problem, we find similarly, these are also easy problem, but you have to first catch the problem. Two blocks in contact sliding. That means there are two blocks in contact, one here, who are sliding down. Inclined surface of an inclined 30 degree. The friction coefficient between the blocks are mu1 and mu2. Friction coefficient for the 2 kg block is mu1. Friction coefficient for the 2 kg block is mu1. So friction here is mu1. And friction coefficient for the 4 kg block is mu2. So the friction here is mu2. The question is, calculate the acceleration of the 2 kg block. That means they have not asked anything about the 4 kg block. They have asked the acceleration of the 4 kg block. What is its acceleration? Now, before coming to this conclusion, coming to this problem, I want to touch upon a little part of the theory. Let's revisit the theory. Theory, you don't have to write down when you solve this problem. This theory is for your understanding the problem. Let us say there is any inclined plane of angle theta and an object of mass m is lying on it and trying to slip down. Now we know that this object has a downward gravitational force mg, and it has got this mg has a component of mg cos theta normal or perpendicular to the surface, mg cos theta perpendicular to the surface. It has another component which is mg sine theta, which is parallel to the surface. Now, if it tries to draw, there is always a frictional force, small f, which will oppose to its downward motion. And there is a reaction force R. This diagram you already know when you are in your, but for this, and let's say this mass of this body is M. This is a general case, which is applicable everywhere. In this case, we find that reaction force R equal to mg, reaction force R equal to mg theta, and also we find frictional force F is equal to mu R equal to mu mg is equal to mu mg cos theta. Now, if this body is trying to move down with an acceleration A, then using the force equations equilibrium, you can write that downward force mg sine theta minus the opposing upward force, frictional force mu opposite frictional force is minus mu mg will be equal to mass into acceleration. From here, all m gets cancelled. So we find acceleration A is equal to g multiplied by sine theta minus mu. This is a very important question, you can say, which is useful always. What we find from this equation? We find acceleration is independent of mass. This is one decision. Acceleration is, or rather we write, acceleration does not is number one decision. That is, whenever a body is trying to slip down a inclined force, the acceleration or its motion is independent of its mass. It will take up the same acceleration whether it is a 2 kg body or a 4 kg body or a 10 kg body. Right? And second thing, what we observe from here, mu is here. So if mu is more, then this terms becomes larger. That means acceleration becomes smaller. So we write as mu increases, acceleration decreases. Second conclusion is obvious. Mu increases means there is more friction. If there is more friction, then there will be less acceleration. So this is the part of the general theory which is useful to remember, and that will make it easy to solve the problem. Now coming to the problem, in case A, the values of mu1 and mu2 is given. Case A, where mu1 is equal to 0.2 and mu2 is equal to 0.3. So which mu is higher? Mu2 is higher. Mu2 is the 4 kg body. So 4 kg body, mu2 is the 4 kg body. If mu2 is higher, then from here we find its acceleration is less. And for the 2 kg body, mu1 is smaller, so acceleration will be more. So what do you find? 2 kg body, this 2 kg body will try to slip faster than the 4 kg body. So we can write here the 2 kg body tend to slip faster than the but of course it cannot slip faster because both are solid material. So what will happen? 2 kg body will press against the 4 kg body. So we can write, so the 2 kg body will press against the 4. This 2 kg body presses against the 4 kg body. What it means? It means that both of them will come down together. That means that means both will come down. Both comes down together. Then what do you do? Consider both bodies together. Consider both bodies. Consider both bodies together. If you consider both bodies together, then we can write the force equation. Then downward force will be 4g sine theta plus 2g sine theta. That means 6g sine theta. That means we can write downward force is 4 plus 2 multiplied by g sine theta. This is downward force. And what is upward force? Upward force is for 4 kg. Upward force is mu 4g cos theta. So it is mu 2 4g cos theta, mu 2 4 theta. Another upward force is mu 1 2g cos theta. This is equal to the total mass of the two bodies together is 6 multiplied by its acceleration A. This equation we find theta is given 30 degree. We know from here theta is equal to 30 degree, g is equal to 10, values of mu1 and mu2 given, mu1 and mu2 given. If you use all this formula, you will find acceleration A is equal to 2.69 meter per second square. So this is the acceleration with which both bodies come down. And since both bodies come down together, that means this is the acceleration of the 2 kg mass also. Now, we go to the second case, B. mu1 is 0.3, mu1 is 0.3, and mu2 is equal to 0.2. Here, what do you find? What? That will for the 2 kg body, mu1 is more. So its acceleration will be less. So we can write mu1 is larger or its acceleration will be less. That means they will come, that means they will come separately. Since acceleration of the 2 kg body is less and acceleration of 4 kg body is more, so obviously 4 kg body will slip faster and 2 kg body will slip behind it, keeping a distance. So now we can consider only the 2 kg body. Consider only kg body. Consider only the 2 kg body. The equation we find downward force 2g sin theta minus upward force 1 multiplied by 2g multiplied by cos theta is equal to its mass 2 into acceleration A. From this, if you find out, if you calculate this, put the values of g and sin theta and mu1, you will find A is equal to 0.4 meter per second square. That means in the second case, the smaller body, 2 kg body, will trail behind the larger body and smaller body will come down with an acceleration of 2.4 meter per second square. Similarly, here you can, if the question asks, you can also separately find out the acceleration of the larger body or 4 kg body. Okay? So next day, we shall see another problem.